Okay, let's try to look at the next expansion over here. So what do I have? I have x minus 3 and everything, I'm going to raise it to the power of 2. Now take a look at this. Now this is going to be very similar with this, right? Very similar. But what's the difference? The difference is going to be the sign. One of them is a positive and one of them is a negative. All right. So again, I would like you to try to work this out and expand it and let's see what you get. All right. But of course, I'm just going to show this step by step again so that everyone's the same page as me. Yeah. So if you were to expand this, I can rewrite this as x minus 3, right? X minus 3, okay? If we were to expand this, we can do it the same way as here. X times x, okay, and just multiply this, all right? We will expand everything from the first term first. That should give me x squared minus 3x, right? Okay? So what about the second one? So this guy and this guy over here should give me minus 3x again, and then, don't forget, negative times with negative should give me positive 9, right? If we were to simplify this, I should get x squared minus 6x plus 9, okay? So try to take a look at this expression and this expression over here, okay? Looks the same, right? What's the difference? Can you spot the difference? Okay? The only difference between this and this is the sign over here. Is this sign. One of them is negative and one of them is positive, right? Okay? So that's the difference over here. Huh? Now before I continue on with all this expansion, I'm going to share with you some common mistakes over here. Now a lot of students confuse negative 3 minus 3, in fact of any negative number, with this. Alright, can you see what's the difference here? All the numbers are the same, they are all negative 3, but however, the operation are different. So for the first one, it's negative 3 minus 3, alright? So negative 3 minus 3, if you look at your number line, if this is 0, that's where negative 3 is. I'm just going back 3 more steps. 1, 2, 3. And that should end me up in negative 6, right? So my answer here should be negative 6, alright? But in this case, this and this have the same meaning. Multiplication, alright? When you multiply, remember, negative multiplied with negative should give you positive. So in this case, this answer over here should be 9. And this as well, right? So remember, when does the sign change? Is when you multiply or when you divide, okay? So please be very, very careful with that, okay? All right, okay? Oops. Now, over here, if you look at this is very similar to this example over here, right? So again, we can come out again with a general expression, all right? Over here, we can come up with a very general expression over here, and I'm going to show you, where does all these things come from, all right? So my general expression over here, okay, so when I have x minus a squared, all right, what will I get over here, all right? Okay, so again, we have already shown that this is very similar. So for the first term, all right, we should get, we should get x squared, okay? And then the second term will always give you a negative 2. In this case, that's going to be negative 2ax. Okay? All right. And the final term is going to always give you a positive a square. Okay? Now compare this expression and this expression over here. So basically they look the same. The only difference is one of them is plus and this is minus over here. Okay? Now what I'm going to do next is I'm going to prove to you, like where does all this is, what is this? I don't want to, like, you need to show that, like these are not just a bunch of numbers and alphabets just jumbled out together, because all these things make sense, right? So I'm going to transfer this thing like into this diagram to show you how does this make sense. So again, look at this. Since we have the same length and we square it, once again, we are dealing with a square. So let me draw my square again over here. Let's draw a bigger one. All right. Now I have my square here. So let's put out some information. So where is this guy? All right, because I'm dealing with a square, I want to identify what's my length first, okay? So this guy will tell me, but this time I have x minus a. So where do you think x is, all right? So I'm going to show you where x is. X is going to be the whole length over here from top to bottom. That's going to be my x. Where is this a? This a over here is going to be from here to here. Right? Of course, it can be longer if you want to, but for example's sake, so I'm just going to keep it short, so you can see what's going on over here. A. Alright. So again, since we are dealing with a square, my height of the square should be the same. So from the top all the way to the bottom, that should give me an x again. And let's just say roughly my over here to here, that should give me a. Okay? So I have all this measurement now. So can you tell me what's x minus a? All right? So x minus a is going to be here, right? All right? This length over here, that's going to be x. Oops. That's going to be x minus a. Same thing as this guy. Okay? So this whole thing again is going to be x minus a again. Now, all I'm going to do is I'm going to draw some line again that is very similar to this. Alright, so I'm just going to draw out. Okay, so again, oops. Now we have our information here, alright? Can we find what's x minus a square in this diagram? So we have identified that this length is x minus a, this length is x minus a. So x minus a square is this guy over here, right? This whole thing, it's x minus a square, right? So again, we are dealing with a perfect square over here. Okay, we are dealing with a perfect square over here. Now we have find who is this guy already. Now who's this guy? X squared. All right. So where are my x? All right. My x is here. My x is here. So x squared is the expression for this whole square. Can you see that? The big square, the whole square. That's x squared. So in other words, what is this expression is telling me? For me to get this, I have to get the whole square and subtract this guy. All right? Subtract over here basically in mathematics means take away. I need to remove something from this square. In fact, I need to remove two of them. That's why it's two. Two of ax. So let's find who is this guy over here. Who's ax? Where's ax in the diagram? Can you see that? All right. So again, let's try to look for a simple one. We found our a here. What's x? We know that this is x, and we know from here to here, That's x as well. So AX is basically this long rectangle over here, right? Okay? So they said I have to remove two of them. So one of them is here. Where's the other one? It's gonna be this one over here, right? That's my other AX. Can you see that? 1AX, 2AX, that's my 2AX. But what do you notice here? Do you notice here that I have accidentally removed these boxes 2 times? Alright? So because of that, I will compensate by adding another A square in. Okay? To show you this properly, I have prepared some materials so that you can see what's going on over here. Alright, I'm gonna put this like so that you can see what's going on over here. Okay, now we are going to transfer all this information down here. So what we have looked at, we already know that this guy over here, that's x minus a square, which is this guy. So for me to get this guy over here, I need to take the whole square, which is the whole blue square over here. I need to remove 2 things. I need to remove these 2 rectangles over here. I need to remove this rectangle, which is my AX, right? And I have to remove this rectangle. Okay with that? Now I'm going to show you, I'm going to like literally remove it. I'm going to tear this up so you can see what's going on here. So I'm going to remove one of the AX first, okay? I'm going to remove this. Right. So what have I done? I have removed one of the AX over here. But I have shown you in the picture, where's the other AX? It's this whole rectangle, right? But look, I have a missing part over here. I don't have my complete rectangle, the complete AX. So to compensate for that, alright, I will add another small square over here. Pop. And who's this guy? Alright. And this guy over here, that's my A square. That's why it's written A square over here. Alright? A, so which means it's A, which means it's A. This expression of this square inside here, that's A square. Now if I add another A square over here, do I have another AX now? So I can remove 1 AX, 2 AX, right? But in order to make this the second rectangle here, the second AX over here, I have to add a small square over here. Alright? Okay? So right now, I can remove this guy. Okay? I can remove this guy right now. So what am I left? Alright, what am I left? The thing that I want. Okay? So I'm just going to put this over here so that you all can refer. So this A square, alright, you have to know that I have to add in. Alright? I have to add this in to make my other AX. Okay? Alright? Remove one. But again, when I remove this, I have not enough. That's why I have to add this in to compensate for the AX. So I have another AX to remove. Alright? So let's put this back in. Okay, so that's the proof, okay, for this expression over here.